Testing. Gonna make sure this isn't too quiet or too loud. Oh yeah, in the chat thing. I always have to do that. Give me 1 sec. Alright. Should be good now. Alright, what's up guys? My name is Cherno. Welcome back to the Game Engine series. Feels like a little bit of time has passed since the last time we had a Game Engine series episode. I didn't stream last week because I didn't have time, unfortunately. But I do have time right now, hence the streaming. So I set the mode, I think, to like low latency. So hopefully this is going to be a little bit more like the chat messages will be a bit more relevant, I guess. Okay, good. This is working. All right. So, yeah, how's everyone? Today we're gonna continue working on the content browser thumbnails that we started. I'm just gonna do a bit of programming. No big deal. So let's see. Let's see where we left off last time. So last time, I think we basically got it working, but we weren't caching it. So I think that's kind of what we wanted to do. If we jump on into the code, you can see that we're we had this little step-by-step guide here, and get or create thumbnail was the function that we called from our content browser panel. So basically, if it's not a directory, we need to load a thumbnail for the file that we're looking at, and and we're going to try and load that from the cache. And the result here is basically, well, like what will happen here is, you know, we'll grab the last write time of the file for the cache, so we're not really using that part now, but oh no, we are. So that's right. Let me just demonstrate what we've got so that I kind of jog my memory as well, and we see what's up. So because I remember what I was doing. This is a sandbox project, right? That we were. Oh yeah, no, it wasn't sandbox project. It was the face run, I think. Because sandbox project's a bit weird, I think. Oh well, actually, this is Big Hazel. So I think Hazel has a 2D directory. Face run. That's funny. I tried to open a Big Hazel project in Little Hazel. That did not work. Yeah. So this guy. And we had like some issue with 32-bit versus 24-bit PNGs as well, I remember. But if we find this on disk real quick. Here's face run assets. If we take a look at our content browser over here, make it a bit wider, and we look at, I think we have to be in asset mode. No, we're in file mode. Okay, so if you're in file mode, then you can see we have all of these thumbnails here, and it will basically be aware of, it will refresh the thumbnail if the last write time has changed. So if the timestamp of the actual file, like when it was modified, has changed, then it will refresh it. And we can see that if we go into, you know, this, and we open it with like Paint. Oh, not Paint 3D. Let's go Paint. Then I can draw something here, and then hit Control S, and you can see it's reloaded it in Hazel. Which is pretty cool, right? So that's what we did last time. Yeah, we were in debug. Let's try release, because I wanted to open that other folder I remember we had. But basically, that's what we did last time. We just go through everything and see if, like, what the timestamp is, and if it's different, then we reload it. Otherwise, we just use the one that's in the cache. The thing is, though, the cache at the moment is like memory only, so we regenerate the cache every time we start. It doesn't get written to disk, so ideally it would get written to disk, of course, because did I open the wrong thing again? Yeah, I think I did. Face run. I don't know what that other project file is. We should see why that's not working. Yeah, so it doesn't get written to disk at all, so it gets regenerated every time you start every time you start It's a little bit loud. I feel like it is loud. I really don't like this though, because it's either too loud or it's too quiet, because this gain control is terrible. So testing is that, it's kind of, yeah, all right, whatever, I'll leave it like that. Yeah, so the problem is that, yeah, it's not persistent at all, which, you know, is a bit annoying, I think, but there's also no reason for it to be persistent right now, because what we're like, it's kind of like, you know, if you think about it this way, if you have a cache, and if all you're going to store in your cache are images, as, you know, as is, then it's like, well, do you need a cache? Because can't you just read the image? You know, like, instead of reading the cache file and being like, oh yeah, this is the thumbnail. If thumbnails are in fact just these images, you might as well just read the image. Which is why we have to do more than just simply store them on disk. We have to transform them and downsize them into the right kind of thumbnail size, or, you know, at the maximum, let's just say thumbnail size, which at the moment we can blow it up to 512. So that would mean that no matter what the resolution of this is, we're going to store it at 512 or below. So if this file specifically, I think, is you know, 783 by 787, so we would downscale it to 512 by 512, or like, well, not really 512 by 512 maybe, but we'd keep the same aspect ratio. Is the music too loud? I like the music a bit quieter. So let me know if that music's better. So we downsample it and make it smaller. But then also the other big benefit is that clearly, like, you know, these are being stored as PNGs, whereas we would store them ideally in a GPU compressed format, or maybe for now just as raw pixels. And the upside there is it's going to be a lot faster because we don't have to decode anything. We just immediately upload it to the GPU, either compressed or not compressed. So that's going to be quite a good thing to do. So there's that problem, and I think we'll probably work on that today. But then the other thing is, if we go into, say, textures, I added this Hazel file logo sequence. So if we open that, you can see the whole editor freezes. We're in release mode, so it shouldn't take as long as it did at the end of last episode in debug mode. But you can see it's literally frozen. I can't do anything because that folder happens to have like 300 PNGs, I think, in it. And there we go. So that took like, I don't know, 20 seconds or so, probably. And you can see we've got 300 PNGs here, and it loaded all of them, and I am in fact looking at all of them, and it's nice to see all of them. But also they're like, this is probably using quite a bit of memory because it's loaded, you know, how big are these? These are 1 meg each, and that's as a PNG, but it's 2160 by 2160. Oops. So 2160 by 2160 by, if they're just RGBA, then that would be 4 bytes per pixel. So that's 18 megabytes of raw data per each of these, times 300, which is 5.5 gigabytes. Is that really true? Are we really using that much GPU memory? Yeah, I think we might be, because check this out. So I've got 10 gig of dedicated memory, and looks like we're using like 8.3 or something. So that's very, very bad. And if I close Hazel, then yeah. So Hazel just then was using like, I guess we did the calculation, like 5.5 gig of VRAM, just because we opened that folder, which of course is unacceptable, especially for thumbnails. So you have to consider some of these things. And that could just be the beginning. Like, you know, I happened to open up this, right? Like, I happened to open up, and you can see, by the way, even Windows Explorer, it takes a while to kind of load all of those. But I just opened up this folder, and it happened to have 300 items in it. What if it had 3,000 items in it, right? Like, you have to think about kind of how you're dealing with this. And you can see, by the way, that it's not, like, Windows is not loading all of them. Like, now they're basically all loaded, but they are getting unloaded somewhat, or at least they're probably getting cached, but they're getting unloaded somewhat. And also, it only initially loaded what was in view. So we're probably not going to do anything that complex, just because it makes sense for Windows Explorer, because that's important, you know? I don't think it's that important. I don't think it's that important for us to spend that much time doing this. It could definitely be something we could do in the future if it becomes a problem, because ImGui also, at the moment, the other problem is that, of course, ImGui is actually trying to render every single thing in that directory, right? So if I open this up again, and then we can actually watch the dedicated GPU memory usage here, just climb. Yeah, then you can see, once it's done, you know, it's obviously processed the whole directory, even though we can only see this much. And so it's, but the thing is, it's not just the fact that we're loading, you know, all 300 images immediately. The reason why we're loading all 300 images immediately is because ImGui is actually trying to render all 300 thumbnails every frame. Now, they get clipped and it doesn't make it to rendering. Like, the GPU is not rendering 300 thumbnails and all the labels attached to them, but it's trying to, because if you take a look at what's happening here in our code, what are we doing? Like, we're inside the content browser panel on ImGui render. This is our content browser window. And then what are we doing? Oh, we're going through every single directory entry inside that directory iterator. So every single entry inside that folder, that directory, every file, every folder inside that directory, we are going through it. And what are we doing? We're actually full on being like, hey, ImGui, draw me an image button 300 times. All of this is happening 300 times. So that's kind of what I'm trying to point out here, that it's not like, the solution isn't really, oh yeah, let's just not, you know, maybe load 300 thumbnails at once. It's also why, like, let's take a look, let's take a step back and see why we're trying to load 300 thumbnails at once. And the reason why is because, as far as like this code is concerned, we actually have all 300 in view. It's only later on that it decides that, oh, actually no, you know, 99% of these aren't visible, let's cull them. But we need to do the culling a little bit sooner than that. So I think what we might do, I don't know, there's two options. Maybe I'll ask you, Stream, like what you think we should work on today. But there's kind of two options at the moment that we could work on. And one of them is we could optimize this part, right? Because clearly, like, I wasn't really going to spend too much time on this, but then, like, this is very unacceptable, obviously. And we might as well maybe optimize it to the point where we only load what's in view. So if you think we should do that, let me know. The alternative is, instead, we focus on downsampling the thumbnails, and then we store them on disk in the thumbnail cache. So I think we introduced this in assets, I think thumbnails.cache file, which at the moment doesn't really exist. It's like, I think if we go to the thumbnail cache, it's this. So we have this like thumbnail.cache file that we arbitrarily created. That's kind of it. We're not actually storing anything in that file on disk. So those are the two things we could work on. Either downsampling the images, storing them persistently in a thumbnail cache, you know, database file, or looking at how we can reduce these 300 images to kind of only, you know, instead of going through all 300 items or going through every single item inside that content browser, going through every single item inside a directory in the content browser item, and then discarding it later, to actually basically deciding up front what gets culled, what's visible, what should get rendered, and then we can go through and only load the stuff that is. So what do you guys think? I could do a little poll, but I guess I can do a little poll. Okay, I started a poll. So you guys can vote on the poll. And then we will see what we're doing today. I'll let it run for like a couple minutes. We're probably gonna do what we don't do today. We'll probably do next episode. So I wouldn't worry about it too much if you're worried that we'll never do it, because we will. Okay, so far only render thumbnails and viewers are winning at 65%. Is it possible to do both? Well, yeah, probably not today, but overall, yes. Like we will be doing both. Okay, I'll give it like 2 more votes. I mean, that's not going to change anything though, is it? Alright. Okay, so only render thumbnails in view going once, going twice, and end poll. Alright, so only render thumbnails in view, 61%. Okay, so how do we do that? Well, there's actually something inside ImGui that helps us with that, obviously, because otherwise it would be a little bit difficult for us to do that ourselves, just because it would involve kind of diving deep into ImGui. So if we go to the content browser panel, and we'll have to think about, like, this might be a little bit tricky, I'm not sure yet, because I haven't done this exactly with the content browser panel. But there's something inside ImGui, which it's called like a clipper or something. ImGui list clipper. Right, so let's take a look. So I just closed that. So here it is. So manually clip large list of items. If you're submitting lots of evenly spaced items, and you have a random access to the list, which we do, you can perform coarse clipping based on visibility to save yourself from processing those items at all. So that's what we want to do. So you can see this is in the ImGui header file. It's got some documentation here, and it's got some usage here. Now, not only does it have usage here, it's also something that we can. I think ImGui, the demo file, also has an example usage there. Are you going to switch to Vulkan? Eventually, yes. Big Hazel has been Vulkan for like several years now, but it's just we don't really have a huge need at the moment to switch to Vulkan here. So we're going to do it a little bit later. Okay, so let's grab this. And then we'll go through here and we'll decide what we need to do. So the directory iterator is going to give us every single directory that we potentially have to process. So the thing is, we do need to do some kind of pre-processing with this, because we need to know, for example, how many elements we even have to render, and then we have to do the rest of this code. So what I'm going to do then is we're going to pre-process this by going through this directory iterator first. It would be good if we could know a little bit more information, because this is just an iterator, but it's probably going to have, well, it might, yeah, probably it might not though. Like, I'm not sure if this iterator will have a size. Probably not. Like, I'm sure we could probably find out in the current directory how many files we have, so that we know how much space to make. But because otherwise at the moment it's gonna basically be like, you know, if we have a directory entry, And then we have a vector of directory entries. We don't know how much space to allocate here or anything. And then we'll just end up pushing back. Which is not the best. Can do it in place back. And then we'll push in all the data we need, basically. So it looks like we need a path. We need... because, well, actually, like, I'm just wondering if maybe we can avoid this. I mean, we could, because we could just go plus plus a bunch of times. Maybe that would be better. It's just, like, it is going to be obviously not great for performance for us to just go through and copy every frame a bunch of metadata about potentially 300 files into this just so we can then process them and clip them. You know what I mean? So I'm considering maybe we shouldn't do that. It's just I do need to know how many elements we have though. Yeah, let's try and do this in a bit more of a smart way. How about that? I'm not sure if this will work yet, but we'll see. It's just, it's potentially dangerous to do that, you know? Ugh, directory iterator. Just don't know if there's a good way to do this. Yeah, I've forgotten exactly how to use this. As in, because this code doesn't seem to match what it's saying to do. Oh, no, it does. It's because clipper display start and end is, yeah. No, that's correct, yeah. This is actually correct. So, yeah, so what we need here is we need to know, first of all, like, how many entries, and then we need a way to advance iterator to starting entry, basically, which is a little bit annoying potentially. I mean, that does avoid a copy. Because, like, we could basically we could do this. I don't know, like, there's probably a better way to do this, but you could just do something as simple as that. I don't generally like one-line for loops. And that will obviously give us our count. Let's just do this way first, and then we'll see if we can make it a bit better. And then, so the first time this runs, it's definitely going to display the first element. So, and then this is, I mean, this is always going to be contiguous as well, so we probably don't need to do this specifically. So it would probably end up being something like, because here, advance to this. And so we kind of, we would have to go through and basically do, we'd have to get an iterator and we'd have to advance that iterator this amount of times. And then we could go through show clip display start, and then obviously that would be our thing, and we would do iterator plus plus at the end of it. So it's a little bit messy. Yeah, so it's just, this is, the only thing I don't like is this. This is okay, I guess. It's kind of like traversing a linked list. But then, which is kind of what it is anyway. But then, if we go through this, which is also fine, as long as we should have enough. We can we can check the iterator if we need to, but if we go through this, so this is where we do the rendering, right? So we can do that at the end. And so this is basically what would be here, right? So we can copy this for now, paste it in here, and then directory entry would be basically that. I guess you could do const. So that's, yeah, that's basically it. So this is the old code. Get rid of that for now. Yeah, and so I don't know, like I don't know if that would work. But the idea here obviously is that we the first time we go through this, it's not going to do this. And this will just be, so the way this works, I can kind of explain it a little bit now that I've written it. But the way this works is that you specify how many you have. So like we have, so let's just say 300 entries for that folder, right? For that directory. So when you jump into this while loop for the first time, so it's the first time, then clip a display start and end will be 0 and 1. So this for loop is just going to run once. It's not really a for loop. And so what it's going to do is it's going to go through all the code that you plan to have to render a single element, which in our case is kind of like, you know, a bunch of text and then like a thumbnail or whatever, right? So then that way it can just figure out how much space it takes up basically and what it needs, like what the bounds are. And then that's why this is in a while loop. It's going to go back out. And it's going to reset the ImGui cursor to be back into like the top left so that the next time it actually does render something, it'll overwrite this. So then it goes back up here And now because it knows the size, it can do a calculation to figure out what's actually in view based on your scroll position and the size of your window and all of that stuff. So now it knows. So it's going to go here, and since it knows clipper display start is now no longer going to be 0 potentially, it might be something like 30, and this might be something like 35 if you can fit, you know, 6 different or 5 different thumbnails, right? So then since this is 30, we need to advance the iterator 30 times to get to the 30th file, and then from then on we'll just start rendering everything, and we'll only render 5 elements in this case. So that's how it works. You have to advance the iterator in the second for loop. I am. So at the bottom I'm advancing it every iteration. I could do something like this. Maybe. You could do that here as well, but this is probably more clear. So let's give this a go. I don't know if this, as I said, I've never tried this before with like directory iterators or anything. Okay, I think I just got rid of a curly bracket. Or did I? Where am I missing a curly bracket? Okay, here I guess. Ah, I must have... It's this. Alright. So that didn't work already. Let's do this in debug. Items height is greater than 0. It means item 0 hasn't moved the cursor vertically. Oh. Oh no, this doesn't work horizontally, does it? That might be a problem. I think this is a problem. Because, yeah, I guess it's a list clipper. So this is specifically for lists. That is not good. Well, that sucks. I mean, it sucks, but it's still useful, I guess. Like, we'll just have to potentially do it in a different way. I don't understand, like, okay, so if I haven't moved it vertically, though, who cares? Then just allow everything. Like, I'm not sure why that's not working. As in, I'm not sure why it wouldn't allow me to not move that. Like, okay, so you haven't moved the height. Well, that means that it's fine, isn't it? Okay, I guess, well, the real reason why is because it's expecting that if you do, in fact, have an item, then you are going to move it. But all we do is next column, which isn't going to do anything because, yeah, we're not going to go to the next row. We only go to the next row if we don't have enough space, as far as I'm aware. And so it's expecting that if you do have an item, it is going to move it. It's a bit of a shame that it works that way, because this could have still worked, obviously. It's just you'd never clip anything horizontally, because we don't actually have a horizontal scroll bar anyway, so it's not like that's a thing here. The column count is 7 at the moment. So one thing we could do technically to fix this, because the thing that's happened, like one thing that is true is that if this is our content browser panel, then as we go through, like if the column count here is set, like okay, however many columns we have, we're guaranteed to show at least one row that is obviously going to include all of the columns, right? Because the columns are determined by the panel width. So what I'm saying is that if this is saying that we have 7 columns, which it is, that means that we definitely have 7 items to show. Like that's a fact. It might not be 7 items, like it might be less. Like if the director only has 4 items, obviously we're only going to render 4. But my point is 7 will definitely fit no matter how big the thumbnails are. Because if you make the thumbnails big, then obviously the column count's going to be like 2 or 1 or something if your thumbnails are this big. So I guess what I'm saying is that we are guaranteed to always render or be able to fit onto the screen the entire array of columns that we have. The entire width of the column, like the entire span of columns or whatever, right? So what that means is that what we could do to trick this thing is we could kind of begin to treat it more like a list, in the sense that instead of treating this as like, okay, we have 1, 2, 3 discrete items, and we go through and every time it's like, this is a discrete item, this is a discrete item, we could bundle them up into rows instead. Because if we tell this list clipper to treat this as a row instead, then obviously at the end of the row, we move the cursor down vertically. That's how it works. That's how rows work. They're vertical. It's just that if we treat it by element, then that could be a column. Like that could just be moving horizontally. And then at the end, it's going to move both horizontally and vertically. So we're going to go back horizontally to the beginning, and then we're going to drop down a line. So what I mean is that we can actually over here we can I did something. We can process this as columns. So if I go through here, let's do C for column. I'm not exactly sure how this will work, by the way. It's like a half-developed idea. Now, obviously what's going to happen, though, is that if we happen to have less of these things, and we have to advance the iterator every entry here. If we happen to have less of these than we have the span of, then that's going to potentially be an issue. Because if this is going to try and go through 7 times, but we don't have that many elements, then that's going to be an issue. So one other thing we could check is to basically make sure that iterator doesn't equal this, I think. But either way, the problem here is that we need to go down to the next column. So I have a feeling that this might not exactly work, because if we do in fact run out of this, then however much was left needs to be accounted for somewhat. Otherwise, we're not going to advance lower. But this could also be something that we do for the first run. So what would I do here? Let's take this out. And then maybe we could say that if we get to the end of this, and if this is the first run, and C doesn't equal column count, then what would we do? Go through the difference. This seems ridiculous. And just do next column so that it will advance vertically. I don't know. This is getting a little bit messy. I'm not really enjoying this. I feel like this is a bit not that great. Okay, so this isn't working because it hit the end of the iterator. So this, okay, so first is false now. Display start is 1 apparently. Okay. I mean, that's a bit weird. We never reset the iterator. So I think the iterator should be here. Yeah, it should be. That might have been a promising crash, actually. Okay. Well, it's all here. And also, we don't have 7. We have 5. So, what's up with the column count? Okay, it is 5. Maybe that was before other panels were loaded, and so we had more space. Okay, so we have a huge amount of space here, which I'm guessing is because of me. And also, this seems super weird when I scroll. So it's definitely not exactly working. Oh, also, I just realized it's duplicated. Half the stuff is duplicated. Yeah, I know why, actually. That's to be expected. It's because, remember, this is to do with, if this is to do with columns, and we know that we're fitting that many columns in, then it's, oh, but we are doing iterator plus plus here, though. Aren't we? Ah, it's this, I think. Yeah, it is that. I think it's that. So, yeah, so we'd have to also do this, kind of. Really? I think we'd have to do this. There's a lot of vertical space, which I don't like. I think that's a result of us doing this. Although that's not running, though. But we don't have the duplication anymore. And does that work? Okay, so that seems, because we're in debug, remember. So it loaded, I think it loaded just this. Actually, maybe a bit of this. So you can see scrolling is slow because it's loading them as we scroll. So there we go. So that's kind of fixed. Let's go through and we'll figure out. So obviously, like when we go to... So first, so I want to have a little item render count. So every time we render, as long as first is false, because that doesn't really count, we'll do item render count plus plus. And I guess we'll measure this per frame. So let's just see how many items we're rendering. Will empty space be as much as there are actual rows? I don't know. It's probably just an error I've made somewhere. Okay, so we're rendering zero items apparently. What? That's not good. Because remember, the first time we're not supposed to render this at all. But it's clearly working when we scroll down, so this doesn't really make sense. Oh, look, it's just adding it. Ah, maybe not. But yeah, it's way too big as well. Yeah, what's really weird to me, I feel like this isn't really quite working correctly, because the first time this goes through, but it is, but it isn't. Like, the thing is, the first time that it goes through, it's supposed to... Yeah, the first time it goes through, it's supposed to just do one row. Right? This is us doing one row, or at least it should be. So we're supposed to do one row. Now, once we've done one row though, if that row happens to have less items, and it is still our first time, then, I might be reusing I. Maybe that's the problem. Would it be though? Probably not. I'll call this extra. So if we have anything left over, column count minus C. So if we only have 4 items, but column count is 5, then let's do that. Then we'll have like 1 left over, and so we'll just go next column just so that the cursor advances to the next line, is basically what I'm thinking. But it still says 0 items. So let's go through this because it's a bit weird. So we know we have 5 columns. Yes, we do in fact have 5 columns. We actually got 5 items as well. So we're going to count this first. We're going to figure out that we have 5 items. Good. So we have a clipper with 5 items now. The first time we go through this, whoops, this is going to be 0 and this is going to be 1, as I said. So this obviously is going to, yeah, it's basically going to run all the way. Oh, no, this might be, okay, I might get this actually. I think if it goes through this and it realizes that the clipper can't step forward, then there's no point in obviously re-rendering it. I think that's what happens. So when we get here, C is equal, so we don't do that. And then that's it. We're not gonna, oh, but we do step again. Why do we step again then? If we've rendered all 5 items. Oh, because this doesn't know. Okay, yeah, I think I get it. So this should be count divided by column count, I think. right? Yes, but it should be rounded up, I think. Right? Yes. Can I do this? Zero. Wait, that doesn't even make sense, though, because this should be... If it's 5 and 5, it will be 1, 7. Yeah, so this is what I was trying to avoid. Okay, so I think let's maybe remove this and have it do it on a float. And then we can cast a result if we need to. That's what I meant to do. Okay, 1, there we go. Okay, so yeah, so we don't have the extra columns anymore. I should get rid of the rendering 0 items thing. Yeah, and you can see that these are being loaded as they're scrolled over. That's why it's lagging. So let's try release. Okay, so yeah, you can see this, like, I mean, you guys remember how long the loading time was before. Now it's pretty, like, it's definitely lagging, but like it's pretty, and then here it won't. But it opens the directory much faster now because it's only generating thumbnails for what's in view. And actually, another way we can prove this is if we just look at the GPU usage. So if you look at the GPU usage here, remember how last time when we opened up that directory, this GPU usage just went up all the way because it used 5.5 gig instantly. So now if you look at it open, you can see we only use a little bit. Yeah, we've only gone up a little bit. And then as I scroll, it's gonna go up. Which is pretty cool. If I just quickly jump down here, it's not going to go up that much. Whereas before it was loading the entire directory. Is it slow because thumbnails are not scaled down? Well, there's a few reasons why it's slow. First of all, it will take some time regardless of how you do it. It's just that you can have it happen on another thread. So if you have it happen on a background thread, then you simply display like a loading icon or a normal item, you know, thumbnail, like just a generic thumbnail while it's loading the image. Kind of like how you saw how Windows Explorer was doing it. Like if we go into here, I mean, these are all loaded, but you can see that there's like a bit of a thing. It's already loaded all of them though, you can tell. Because the first time we went through this, it was not like that. But yeah, so you would use a background thread to do this instead of having it be done like it is now. So that's actually something we can explore as well. But then the other reason is because, yeah, like it's just going to be slower to read PNGs because you have to decode them, right? They're usually, like, PNGs don't have to be compressed, but they can be compressed. And if they are compressed, then you have to decompress them. So it's just a lossless compression. So if you do decompress them, then clearly that's going to take up some time. We could do that on another thread as well, but either way, it's gonna take time. And what we're doing at the moment is we're doing 1 per frame, I believe. Actually, are we? No, we're not doing 1 per frame. Ah, okay. So that's the other thing I was going to suggest. We could just do one per frame. So that's like a bit of a... I talked about this in depth, actually, a few episodes ago, about specifically how you can just do... Instead of having a background thread, you can trick it by just distributing the work over time. So if you try and do the work immediately, then you create a big pause. But if you delegate the work, like if you spread the work out over several frames, then it actually creates the illusion that you're taking less time. Because it's going to take longer, but it's going to, like, you'll be rendering frames of the editor, of the rest of the editor in between that, if that makes sense. So at the moment, what we do, get or create thumbnail, immediately does this. But what we could do, like, just actually, this will be a nice thing to do to end the stream. Med asked, how big is Hazel code base number of lines wise? Well, Hazel 2D, I don't know how big Hazel 2D is, but I know Big Hazel is over 100,000 lines of code that we've actually written, so not including any third-party libraries, obviously. I think recently was like 105,000, maybe a couple months ago. So that's what I can give you off the top of my head. Yeah, so get or create thumbnail. What we could do instead is we could basically have a little void called, let's just do on update, because that's what we use for everything else. And then what I want to do is I'm going to have a std vector of paths, and we'll just call this Q. I don't really like using, you know, double-ended Qs or Qs or whatever in C++. I just use vectors. So we have a Q here. And so the idea is on update, basically what it does, I mean, to be fair though, a Q might actually be useful here because you can just pop something off it. So I actually might use a Q, even though I usually end up not using it. But the reason why is because you can just do a pop, and I think, but pop's annoying, isn't it? It's void. So mq dot front, right? Is that how you're supposed to use it? Front, and then you do a pop. What's the difference between Hazel 2D and Big Hazel? Well, Hazel 2D is the game engine series, so every single line of code that's gone into Hazel 2D, I've written in a video or a live stream. Like, that's all done just by me, apart from the occasional pull request from the community, which I go through as well in a video. And because it's kind of, I'm also explaining everything that I'm doing. So because it's like a tutorial series, like, it's a 2D engine, because it would just be too much to do a 3D engine like that, and it would take forever. It's already taking forever anyway. And it's meant to be like an educational series. Hazel 3D, or sorry, Big Hazel is 3D, and that's more of a serious game engine that I'm actually planning to use along with my team to actually make some commercial games. And that's worked on by around 5 people, including myself. And that obviously happens off stream. I do stream myself developing it sometimes. Well, actually, no, every second week, really. But that's the major difference. The fact that Hazel, like, Big Hazel is like, I would say, a proper game engine and something we're going to ship games with. Whereas Hazel 2D is a 2D game engine, and it's more of an educational series meant to teach, like, game engines. But not even teach game engines, but specifically implement every single line of code, you know, on stream. So that's, yeah, that's why those two versions exist. Okay, so yeah, so what I'm going to do now is this is going to basically, if it decides over here that we need to load the image, it's not going to do it. It's going to defer it. So it's actually going to add it to the queue. It's just going to be like, hey, you know, hey Q, have this texture, because it needs to be there. Now the problem is we need to also make sure that it's not already there, because if this is gonna not necessarily, like, I don't want to add stuff there. I don't want to add stuff to the queue that's already there. So we could either search the queue and make sure that it's not there, or the queue itself could maybe see if it's been evaluated already and then get rid of it. So I don't know, because it might be easier for us to... I guess it would be easier for us not to search it. So let's just go ahead and push it to the queue. And we'll return null. So we've pushed it to the queue now. So we have to go through it obviously here. So we're gonna grab this. I guess we won't pop it, because if we pop it, it'll disappear. Like as in this reference will be invalid. So this is what we're trying to do. And we push in an absolute path, I think, already. So let's just do this. We'll do something here. But we also need asset path and timestamp, don't we? So... Oh, but we don't store any of it, do we? Maybe we should. Maybe we should store it, but not... Yeah, but we want to queue it up if the timestamp has actually changed. That's the thing. Okay, that's fine. Just call it this for now. Wasn't there also an asset path that it needed? Don't know why it needs that, but sure. Okay, so now we have all of this, and then cached image is, yeah, the result basically, and then we can pop. Now, the thing is though, so we're only going to do one per frame if things go well. But if they don't, like, so see this, in this case, we're going to continue because if it's not empty, then, and we managed to, like, we couldn't load this thumbnail. Let's try and load the next one. Like, let's not wait until next frame to do that. We could easily just wait till next frame. It's not a big deal. It's one frame. But if we get 5 frames in a row of things that can't happen, that's bad. The other thing is, remember, what could have happened in the meantime is that we could have, you know, because again, there's no limit to how many of these we can request. So even though these aren't on separate threads, it almost feels like they are, because this function, like on update, will run exactly 1 time per frame, but get or create thumbnail can run X times per frame. And so because of that, technically speaking, like what we could do is we could be like, all right, let's request 5 thumbnails within 1 frame. So A, B, C, D, and E. Those are the 5 thumbnails we've requested. We push them all back to the queue. And then obviously that means that when we run on update, which one are we going to do? We're going to do A. So A has been taken care of. And then next frame, when we're in get or create thumbnail, what do we add? We add B, C, D, E. But we've already got B, C, D, E. So it's like now we have a lot of them to load. So that's not good. So we could search it to make sure that it's already in there. That's one option. And we need to dress this up. So what was it? Absolute path, asset path. So we could search it before we add it, or we could have it be like a set potentially or something. I still want to keep it as a queue though, so that we do it in order and stuff. But the other alternative is just when we're about to process that texture, like as we get thumbnail info for the front, we could check to see if it already exists inside cached images. So if I basically do this here, we're going to look for, you know, this. And if it doesn't equal AND, it means that it's already here. Now, on the other hand, though, you can see we also need to check the timestamp. So this is already getting a little bit annoying, but if we also check the timestamp like this, so basically we're saying that, hey, this is the right thing. Now, on the other hand, what we could do is if else, we could actually remove it if we wanted to, and then re-add it. So that would save us checking this later, but I won't do that at the moment. So if cached image.timestamp equals thumbnail info.timestamp. So if it so this means that we have in fact already done it, then we're going to do our classic pop and continue again. So this I think now should probably work. And again, the fast path is always landing here. So if we go to content browser panel, so we obviously have to deal with the thumbnail cache being updated now. So if we go to thumbnail cache, inside like content browser panel on ImGui render, I guess over here, honestly, we could just update it. So at the end of this function, potentially, we could do thumbnail cache on update. Like that should be okay. So let's see what I've done. Okay, well these all work, and there you go. Look at that. Like, it almost looks like it's running on a different thread, doesn't it? It's not. I've just spread it out one per frame, right? And you can see if I quickly jump down here, I guess it did queue all of them up though. Well, no, you can see, there we go. It's backfilling the ones that I didn't do, see? But isn't that cool how it's just suddenly so smooth? Like, I'm not really noticing any hiccups here at all. And I haven't put it onto another thread. I've simply made it only do one per frame. That's it. You know, and now I can just scroll through this like, you know, smoothly, and it's not really an issue. So that's pretty cool. Like, I really like that concept. So it only fills those that are visible. Yes. So you can tell by the GPU usage, right? Because again, they are still very big, but that's good in a way because it's easy to test. So you can see it's only done this many, but if I scroll down and we like, you know, wait for it to catch up and do that, you can see it's loading more because this has gone up. So yeah. I'll lead code algorithms useful in real world applications. Yeah, some of them are. I think like they teach you different ways of looking at problems and solving them, you know, because it's kind of like in the beginning you might just be like, you know, it's kind of like a lot of students, to them, like, vector is the only data structure, you know? And the thing is, to be fair, a vector is in fact used like 90% of the time. Like, a vector is a very good data structure, or an array for that matter, but it'll usually end up being a vector because your size might not be known upfront, or it might be dynamic, right? But the best thing about the vector is obviously the fact that it's contiguous memory, and computers love contiguous memory. So to be fair, a vector is an A++ data structure, and you should probably use it most of the time. But, you know, if that's all you've been exposed to, like, sometimes to solve problems, right, like a map might be really good or really useful, or like a set might be really good. Like, if you want to go through and make a list of assets to pack into an asset pack, and you have a whole bunch of scenes, then a set is fantastic for that, because it's going to ensure that you have a unique list of just the assets you need. Whereas if you instead use a vector, then you have to go through everything and be like, hey, does this already exist in the asset pack? Because I don't want to add it again, because I don't want to pack that asset twice. Right? That's annoying. So in that case, like, a set is really useful. A map obviously is really useful if you want to look something up by a particular key, right? You could do that with a vector, but you'd have to iterate through the whole vector, you know, well, up until you find the key that you're looking for and do comparisons for every entry. Like, that's not good. Even though, yes, it does achieve the same result, it's not great. And it's harder to write code like that because you have to write that stuff or use like std find if or whatever, instead of just doing .at or .find or, you know, the normal stuff. So my point is that, like, that's kind of like what lead code is in a way. Like, it can, the fact that it gives you all these interesting problems, it kind of teaches you to think outside the box a bit more, and that can be useful to you when it comes time for you to look at a problem and be like, how am I going to solve this? Because instead of just looking at your toolbox and being like, well, I'll just do this, or I'll Google it, or I'll go on ChatGPT. I guess you can probably just ask AI these days. But instead of doing that, you might be like, oh, well, actually, what if I approach it this way? Kind of like that problem I remember from LeetCode, right? So in that sense, it's great because it really does help you become better at problem solving and have a wider variety of tools that you can use to, you know, implement solutions to problems. So in that sense, I really like it. Now, that being said, the downside, I guess, of LeetCode, not only the downside, but you can't just, you know, be on LeetCode and expect to land jobs everywhere, because LeetCode isn't real world experience, and it's just doing exercise. It's kind of like being a mathematician, but you're not doing anything practical. You're just doing exercises. Like, that doesn't really make sense either. Or another analogy might be kind of like if you're a musician and all you do is you play scales and you don't play songs, right? Like, you need to play songs as well because they teach you a lot as well, you know? Yeah, I've done LeetCode in the past. Not too much, though. And, like, you know, I mean, I've only had one job in the industry at EA, but that nothing to do with LeetCode came up there. Like, a lot of it was just... well, I mean, I was, the job was an intern, so obviously they weren't as rigorous with their testing, I imagine, as they would have been if I was applying for like an actual position. But like, I remember that interview was like an hour and a half of just talking, and it was just, hey, here's a problem, you know, how would you solve this? And so... and those problems were kind of real world problems that would have happened on the game engine team, you know? And a lot of them were to do with like OpenGL, for example, specifically, and or like graphics programming specifically. So that, I think that's a much better way to go, rather than, because someone can just do LeetCode and like a lot, you know, if you just spend a lot of time on LeetCode and just learn, you just end up memorizing how to solve certain problems, and then in interviews you can just pull that out and that's it. But that doesn't really help much. So yes. Did you use math a lot for writing the engine? Yeah, there's a lot of math everywhere. I guess especially in like the graphics programming part of it. And like, you know, I mean, there's physics and scripting. The gameplay code generally has math. Even stuff like, you know, laying out UI and calculating bounding boxes and rendering bounding boxes and culling, and there's lots of different math everywhere. Did your YouTube channel help land the job at EA? Yeah, I think so. I mean, so when I applied for the job at EA, that was 2014, right? We're basically done with the episode, by the way. So I'm gonna end the stream soon, so we'll have a bit of a Q&A if you guys want before I go to sleep, because I'm very tired. So it was 2014. So like my channel, I don't remember how many subscribers I had back then. I could probably look it up, but I feel like I had like 30 or 40,000 subscribers, maybe. So I definitely wasn't, because this is before the C++ series. C++ series I started in 2017. So it was like 3 years before I started the C++ series. So the content on my channel, I don't even remember. It's mostly like Java stuff, to be honest. But I think I did do some OpenGL programming in Java. Like, I think that Flappy... I have this stupid... I guess it's not stupid, but... I guess it is stupid, though, in retrospect. I have this, like... Flappy Bird. Yeah, let's make Flappy Bird. 8 years ago. So that was... Oh, no, that was 2015. So I was already working at EA. Huh. Oh, no. That's the full video. Sorry, that's the... Yeah. That's the let's make it in 3 hours, and it's the whole thing. Yeah, so this July 2014 is where I started. Doing that. So that was like, you know, that was like very, I guess that was a bit more graphicsy programming compared to like, cause you know, that was with LWJGL and we were doing all the graphics kind of from scratch. I wasn't using, like I was using just OpenGL, not like a graphics, like you know, a game library or anything, or a framework. So, but I think the YouTube channel, it helped in the sense that I think the technical director of the studio noticed that I really liked doing stuff from scratch and I liked game engines. And that obviously was very important, yes, because it meant that I was hired onto his team, which was the game engine team. Whereas the job application and the job ad, I guess, was for a game team. So I guess if I didn't have essentially an online portfolio showing my interests, then I guess I probably would have ended up maybe on the game team and it wouldn't even have been a consideration. So, but yes, I definitely do think it helped a lot, probably. Yeah, actually, that's a good point. And the Java custom 3D game engine, I forgot about that. Yeah, the Java, yeah, exactly. Like, I think that's a really important thing as well. The fact that I made, you know, I was doing like a raycasting engine basically, instead of just using Unity, you know, to make a game. That was also probably something that appealed to them, and they were like, well, this is, you know, this is someone who's clearly interested in actually programming engines and doing stuff from scratch rather than just using Unity to make games, which obviously would have been useless to them, and certainly for the engine team. So, yeah, you jumped from C++. Oh, you jumped on C++ from Java. Usually the order is reversed. Is it? No, I started with Java. It's much easier. And then about 2 or 3 years into programming, well, probably even less because I went to university and I had to use C++ there. I only really learned C++ at EA though. Like, I used C++ before that as well, you know, because I had to for university. And I did make like a little Minecraft clone in C++ in 2014. So before I started work, because 2015 I started at EA in January. So I did use C++ a little bit, but like, at my first week at EA, I distinctly remember asking, hey, I don't know what the deal is with like references. Like, do I return this string by reference or do I not? If I'm writing a function that returns a string, do I put the ampersand there or not? Like, I had questions like that, you know, during my first week at EA. So, and remember, I was an intern, so it's not like they expected me to know everything. It was like the opposite. Like in that first week, I feel, in the first couple of weeks, because I definitely wasn't afraid of asking questions. I was so excited that I was just asking questions nonstop to everyone. And they were all really nice about it, which was great. But in that first few weeks, I learned more than in years at university, in the 2 years that I did at university before that, for sure. Doesn't Java have references too? No. So there's no, Java doesn't have pointers or references. Objects are just always automatically references in Java, and primitive types like integers are all value types. How many thumbnails can be loaded at a time right now? Well, it's only 1 thumbnail per frame at the moment. So, and infinite content scrolling kind of thing in Big Hazel. Big Hazel doesn't really even have thumbnails at the moment. It's got thumbnails, like I added thumbnails in a branch, and it's like, and it's a bit more complicated than what we're doing here because it's not just loading the PNGs. It's like the thumbnails that I was implementing was like for 3D meshes and for like materials. So for a material, you know, you have to set up like a sphere, a camera, a scene basically, and then apply the material to that sphere, and then, you know, kind of take a screenshot kind of that. Well, not take a screenshot, but like save the frame buffer output from that, or save that image somewhere that you end up rendering. And then same for meshes. It's like, you know, you have to set up a scene with a directional light, potentially like a skylight or something, so you have some lighting on your mesh. Set up the camera, make sure the camera is sufficiently far away so that the entire mesh and its bounding box fits into view. So yeah, so that stuff is a bit more thing. How does it feel being so smart? Kind of a weird question, I know. Well, I don't know, like, I really don't consider myself that smart. Like, I just don't. Like, you know, I'm not like a competitive programmer. I'm not like, you know, I think as I'm becoming older, because I'm like, oh man, I'm gonna be like 29 in like a little over a month, which is crazy. But I feel like as I'm becoming older, I'm becoming more okay with not being amazing at anything, but I feel like I'm pretty good at a lot of things. And I feel like that's a very useful skill to have, especially if you're making your own way in life, potentially making your own game engine and doing this YouTube thing, right? Like, I feel like if I was really, really good at one thing, then it would obviously be very difficult to run a business that does a whole bunch of different things. And even something as simple as making a, well, not as simple, but even something like making a game or making a game engine, which is kind of maybe it sounds like one specific thing. It's obviously not, and you guys probably know that, because making a game, you have so many different disciplines there. And so if you're only good at one thing, then it can be really difficult to actually make anything, because you need other people who can help you with all these other things. So I definitely don't feel like I'm particularly smart in a particular area, like programming. I wouldn't say I'm an amazing programmer, because I guess the other thing is, like, I definitely enjoy programming. I do like it a lot, but I see programming as a tool that lets me do stuff. You know, like, I write C++ code not necessarily because I love C++ and I could just hang out on cppreference.com and listen to C++ podcasts all day. Like, I do not listen to any programming. You know, I actually don't watch or listen to any programming related material at all. Like, I do, like, you know, stuff like Sebastian Lag and Lagu, and I don't even know how to pronounce the last name, come to think of it. Like, his videos I like because they're creative and they're interesting, and I like the stuff he makes, you know, and it's cool seeing the technical details, but like, I don't listen to C++ podcasts or anything like that. Like, that sounds really boring to me, because it's not like I'm obsessed with the language and I'm like, oh, I can't wait to figure out what's new in C++ 23. Like, I could not care less. Like, I'm interested in the stuff that lets me do my job, you know? I'm interested in the stuff that lets me make what I'm trying to make better. It's not that I'm obsessed with the tools per se. So, yeah. Then how do you learn about technologies? Well, what do you mean? Like, if I need to learn about a technology, I will learn about it. Or if I think that a technology, like, of course I still do research and I see, like, hey, what can we use here? Or what would make us be able to do our jobs better, you know? But it's not like I'm specifically trying to learn every feature of C++ to do anything. I'm sure that I'm missing out on a lot, you know, but I guess everyone is, because it's not like everyone knows everything. So there's always stuff that if you potentially knew that thing, it would help you. But that's just life, you know? And the thing is, like, okay, well, here's another thing. Like, I am interested in graphics programming. Like, I really like working on graphics stuff. And I guess that's like the inner artist in me that, like, I got into programming because I wanted to create images with math and all of that stuff, you know? Like, I'm really interested in that stuff, which is why in terms of like graphics techniques, like, I do love reading about graphics techniques, but like reading about graphics and programming and like path tracing and all of that stuff is very different from learning about the new features of C++. You know what I mean? Like, it's like graphics programming, I feel like that's like an art form, whereas C++ is a tool. And I'm sure that a lot of people might look at C++ as an art form, and that's fine. But I'm just talking about how, like, to me, I'd much rather read a paper on graphics programming rather than like C++ concepts or something, you know? So yeah. All right. Yeah, so I'm not, so to summarize, I'm not saying that I never do any industry related research or whatever. Of course I do. I'm just talking about like C++ specifically, you know? Even knowing the newest features in a language like C++ still requires deeper knowledge and benchmarking to see if the new feature is useful too. Of course. Yeah, like you can't just, you know, and the thing is, it's not like, if you're just like, you know, maybe you work for like a company and then you just mess around with stuff in your spare time and you're not doing anything serious because you have a full-time job as a programmer, then it's easy to evaluate new features. But the thing is, like, if I was to really jump in and be like, can we use something new in Hazel? Like, that's a big decision, you know? Do you have any recommendations regarding learning different programming patterns or architectures? I don't really know. Like, I think that the best thing is probably experience. Like, you can look at other people's projects, you know? Like, if you go to patreon.com/Cherno and you check out Hazel, which, by the way, you can get access to immediately. Just go to git.hazelengine.com, connect your accounts, and you're all good. No, but in all seriousness, looking at something like Hazel, or looking at, like, I don't know, I would say something like Unreal Engine, but it's very big, so it's very difficult to look at, and it'll take you, like, a while to compile and stuff. But if you look at different, like, you even just do a search of game engines, or, like, Vulkan renderers, or path tracers on GitHub, and just look at how they're architecting things, you know? That's probably the best way to do it. And then, but then also be working on your own projects so that you can test out some of these things. And if you really don't understand a concept or a design pattern, try and create as simple of a test around that as possible. So write some code that does that, and like in a way that makes sense to you, and that, like, I don't know, either logs something or visually presents something so that you can see. Like how you learned GitHub automated testing. Yeah, well, see, that was something that I didn't know about, really. Like, I saw it, though, because that's what I mean. Like, when I needed that, when I'm like, I need to do CI, like, I'm like, okay, what solutions exist for that? And I looked at some of them, and then, you know, I didn't have much time, so I was like, maybe I'll just do my own, but that doesn't feel very good. And then people in the comments, which is why I like putting up devlogs as well sometimes, people in the comments were like, no, you should use GitHub Actions, it's good. And then, of course, I ended up using it, right? And then there'll be a video coming out soon where I talk about how that's now running on Linux now as well. So we have Big Hazel now. We have continuous integration for that on both Windows and Linux, which is great. So yeah. Where do you find information about graphics techniques such as GTA or SSR Bloom? I mean, some of them I just knew from working at EA. But I think that, like, I think it's really useful to look at what other people are using, you know? Like, we over here at Studio Cherno and at Hazel, we're not some graphics research division that's trying to implement novel techniques. That's just not our business model, right? That's just not who we are. And so, like, of course, I don't have to find bleeding edge things. I just need to basically find existing techniques that are going to help us achieve our visual goals, right? And so with GTAO, for example, I remember that was like, I did a lot of research on different ambient occlusion methods. I knew that I kind of wanted something screen space, you know? So I'm like, okay, well, screen space ambient occlusion, like, that's something that has been refined and expanded on so many, like, there's so many different screen space style ambient occlusion techniques. Like, what are the current best ones, and like, what are current games using, you know? Like the latest Call of Duty game, for example, like, what AO are they using? And then you just track that down. A lot of the times there are technical presentations, like Bloom. When I had to implement Bloom, for example, that was a big project because I knew I wanted it to be really, really good. And I knew that, like, you know, I even, like, in that bloom video that I made, you can actually see how I went about that, right? I even exported a game, like a very simple scene from Unity, and then put that into RenderDoc to look at how they did all the different passes for that, you know? So there's a lot of, like, there's a lot of that, I think. There's a lot of just looking at existing things, even looking at, like, Unity and Unreal Engine, what AO techniques do they support? And because obviously they've probably done a lot of research and figured out why they want those ones, and also because them being game engines that target a wide variety of hardware, they're probably pretty stable solutions that work on a wide variety of hardware. So that's, I guess that's how I go through that. And then of course, like, you can look at GitHub and just in GitHub search, just type in SSAO or SSR or Bloom, you know. And a lot of the times you are going to get total garbage, for sure. But then sometimes, like, what happened with shadow mapping, because we use PCSS, which is an NVIDIA developed, I think, technique, for our kind of soft shadows. You know, I found a bunch of implementations of that on GitHub, and all of them, none of them worked well, but I think I took code from 2 or 3 of them, put it together, and then added my code and tweaked it a bit more to get it a lot better, whilst also reading NVIDIA's paper, because I could see that, like, NVIDIA's paper was saying one thing and then the code was doing a little bit, something a bit different. I'm like, oh, well, that's a bit wrong. Let me fix that up. And I did, but it was still a good starting point to start from existing code rather than me doing it from scratch completely. And then furthermore, all of those shadow techniques, all of those shadow implementations that were, like, trying to implement PCSS, they just had a model at the origin of the world on a plane, and that was it. Whereas I'm making a game engine, you know? So clearly, like, we need more than that, like, because that's not going to scale on a full 3D world. So then to that PCSS, I added, first of all, the ability for the, you know, the shadow kind of frustums and everything for a directional light to follow the camera and to render what was kind of in view of the camera, because that's something that you don't really need if you just have a model viewer. You can just have the, you know, the orthographic projection for the directional light shadow map just be in the origin of the world and you're done. But then also I added cascades. So I added cascaded shadow mapping to that. So we have 4 cascades in Hazel. So those were things that I just knew how to do mostly, because I guess I worked at EA and I knew that, like, our mobile engine at EA had cascaded shadow mapping, and I could just think about like that, I guess. And, like, I knew it's what's interesting, I think, is that I guess as you become a more experienced programmer, you begin to realize that you don't necessarily need to read code as much. Like, of course, for the specific math of a specific technique, yes, you do. Or at least you need to read the mathematical theory, yes. But to put together a system, like, you can just know the very high level concept of it. You know, like cascaded shadow mapping. So we have, you know, 4 different levels where we just expand the orthographic, like, projection wider and wider, and then we use the tighter ones for the pixels close to the camera. Like, that just makes sense. And that's just something that you don't really need to tell me how to implement that. It's just more like the idea of, like, hey, do this, because the pixels further away, you're not going to see them as much anyway, so the resolution of the shadows doesn't really matter. But it's the pixels up close that are good. Like, so focus on those. Right? How to implement a good picking object. Should I always use ray tracing? I would probably not use ray tracing for that. I would probably use so what you do is you output an additional frame buffer, basically. So you have an additional texture that you render that contains the ID of every object. So if you just have IDs like 0, 1, 2, 3, 4, 5, just have your scene, like, actually we do that, don't we? Yeah, we do that. I forgot that we already have that in Hazel 2D. So, you know, we have, like, there's an entity ID for every entity here. And so what we do is when we do the pass, when we render all of this stuff, how we have all of this picking working. When we do that, we also, to an additional texture, we take in like the entity ID into the shader, just as like a, I guess as a vertex attribute, or a uniform actually maybe. It wouldn't really matter as long as it's one draw call. And then into that other texture per pixel, you output that entity ID. And so then all you have to do is sample that pixel and then be like, oh, this is what value is in that texture. Oh, 5. That means select entity 5 because I've clicked on that, right? Very easy. So yeah, it's really, really good. The only reason why I would use ray tracing is if you were working with 3D geometry and you wanted actual information about the triangles you've collided with, such as like, I want to know the normal at my mouse pointer, because then obviously you can just get the actual triangle and you'll know. So if you're doing like vertex information stuff, then it's, like, yeah, like that's superior. But the problem is, as you can imagine, the beautiful thing about doing it based on this frame buffer approach that I've just mentioned is that it's kind of like a screen space effect, meaning that it doesn't matter how complex your scene is. It's always going to be always going to be constant time. Whereas if you're doing it based on ray triangle intersections, then clearly that's going to highly depend on the number of objects in your scene and also the density of the object. So like if you have a mesh that has 1 million triangles, like, yeah, good luck going through all those triangles and doing ray triangle intersection tests. Like, that's going to massively slow you down. Whereas this will always be quick. And also it'll always be pixel perfect because you're literally sampling the pixel. Like you can see I'm clicking over here and it's literally selecting like this perfectly. So yeah, this is definitely a lot better. All right, cool. Anyway, thank you guys for watching the live stream. We are going to, yeah, next week, I'm a little bit all over the place at the moment. I talked about this, I think, last time. That's why I didn't stream last week, because me and my family are kind of in the process of moving-ish, but also I'm kind of building a new office, basically. So I've been doing a lot of kind of construction work to get that up and running. So I've been spending a lot of time not here in the physical office, and I obviously still have a bunch of videos that I need to keep uploading to YouTube. So because of that, like, my schedule's all over the place. Until that settles down, which will hopefully be around Christmas time, but then basically next year, I imagine things are going to be a lot more stable. So it's just a bit of an unfortunate time, kind of. So I apologize if I'm not being consistent with certain things, but I'm trying my best, and next year things should go back to normal, because I haven't really had much time to work on Hazel either, unfortunately, with all of this stuff. So yeah. So no, I will still stream. There'll still be streams till next year. It's just that what I'm saying is, like, I don't know when, I don't know what day they'll be of the week, and I don't know if they're 100% going to happen every week. But I'm definitely still going to try and do one stream per week. It's just, yeah, like, I can't just pre-book it ahead because I'm not sure what my schedule will look like next week. Cool. All right. Well, thanks for watching, guys. Hope you enjoyed, and I will see you next time. Goodbye.